Yeah, thank you so much. I would first like to thank Indian Chemical News, its partners and sponsors for this opportunity. It is a pleasure and a privilege to be part of such an august panel, and I welcome the panelists. Specialty chemicals is a very interesting field in the sense that there is a lot of interest because of two reasons. One is the investments are not as high as a petrochemical plant, a large petrochemical, cracker, which is, several tens of thousands of crores. And secondly, there's a lot of space where you can compete with China or at least, not be driven out of the business. We are seeing very compressed margins or tolling margins, as they're called, for the petchem, typical commodity polymers or commodity products of the petrochemical cycle. And I remember a couple of years back, when we used to have, a lot of requests from the banks to do webinars on this. And the attendance was off the charts. It used to be 160 people joining just from Citibank, and another we would have for Axis, another 100 people, and so on and so forth. So this is a sector which is very interesting. And carrying on from the last discussion, where how do you counter China, really? How do you counter China? And that's the in a sense, providing some perspective or some, groundwork for this panel discussion, which is new products, innovation in specialty chemicals and high performance materials. So with that, as the opening remarks, I'll just set the context. Specialty chemicals are, of course, crucial to augmenting or providing, some special qualities for effectiveness and, for product usage of the final product. And however, the industry paradigms are shifting at an exceptional pace due to development of technologies such as green chemistry, biotechnology, and nanotechnology. Also across the industries and at a very accelerated pace, we are seeing that companies are needing to reduce greenhouse gases. As somebody pointed out that we've already reached the inflection point of EVs in China. The other interesting, important point is that in September it was about 53% of all the cars sold were in China were EVs, but they are also the pace of electrification or solar power panels that they are putting up is was 330 gigawatts last year. India, till now, we have 170, 180. So this greenhouse point that I was referring to. And obviously, high-performance materials also aim at, providing certain specific, functionality or, like lower, lighter weight, corrosion resistance, etc., and or biodegradability of late. So these would include, biodegradable plastics, water-soluble polymers, and high-performance polymers, etc. So. Starting off, I would like to, begin with Mr. Nagaiah. Sir, in the specialty chemical industry, a great concern for sustainability is perhaps the most important factor that is inciting change. Just to give an example, yesterday I was talking to a Bangalore, a Vapi-based chemical producer, a darling of the stock market. Again, specialty chemicals, so that goes with the territory. They have they're close to commercializing 4 new contract manufacturing chemicals. All of them are just on sustainability. So, sir, coming back, as a result, of this increasing concern of environmental footprint and of chemical processes and their attendant products, businesses are now focused on green chemistry to minimize waste, energy consumption, and toxic emissions. So what are the key trends in the specialty space with respect to sustainability and reducing the environmental footprint of these products, sir?
Thank you, sir.
Mike.
Thank you for Indian Chemical News given this opportunity to talk in front of the Galaxy Indian industries people maybe. The most important thing is in especially specialty chemicals. Everybody is talking about APIs, everybody is talking starting materials, but everybody is talking about the specialty chemical. But there is nobody is talking about the most important is the forever chemicals. Forever chemicals. Actually, forever chemicals, because I will tell the forever chemicals many industries are using. Just take a that Maggie and all these that chips and all these people. So they will coating. But this is very damaging. So what my intention here is to how these things are the damaging in society. Because we are working in the CSIR laboratory, the end people of the society is most important. So most of the specialty chemical difficult to manufacture since there are a intellectual property cost under that is a patent IP is involved. Though China and USA having and Germany and what are some of the European countries having these licensing cost. Government should encourage first most important for R&D to effort specialty chemical with the chemical industries, a public sector and research institutes. This is actually the government side is and giving much, not that much up. And industries also not approaching the things. The thing is, we need to develop new additives, scalants, or surfactant, emulsifiers, or catalysts, or the flowers in India, reduce the dependency on the China. But here nobody is casting. We are buying from the some external maybe China, some other countries. But tomorrow, if they are stopping, what about India? That is, Indian industry must think about this is most important. So we need to develop new bio-based chemicals locally. Example, instead of sodium laurosulfates, like some of the hydrolyzed oats protein, sodium cocaine granate, and these are from the coconut. We have the lot of coconut oil, and the coconut oil is available in Kerala, in Tamil Nadu, some of the coastal area. So the industry must think about this, our indigenous raw materials. Then we will competitiveness in the prices to tell some of the specialty chemical to the rest of the world. We are exporting, there is no doubt, but we are taking the technology from some of the companies of the outside the country. So this is the cost production is very low, because I already just now I told about the raw material cost and subsidies and all these things. And coming to India, that also I told. So what I want to say, the most important of specialty chemicals which are we are buying is the quantity may be less, the thing may be less, but there is a need to develop our indigenous in that whatever our Prime Minister Narendra Modi is telling, number Swachh Bharat and whatever we are telling, Atmanirbhar Bharat. So the industry, Indian industries and research institutes and universities, same time government supports, and sometime just the previous panel is they have to support from the state governments is badly needed for to develop in India, because we have a good skill manpower is there, and we are getting the project from outside, we are doing from the outside. Why they are giving the outside people to India means there is a lot of environmental problem is there. They wanted to give this, we are giving funds and they are doing, and they are marketing to us only. So think this direction from the Indian industries. That is my comments.
Yeah, thank you, Mr. Nagaiah. That was insightful. Coming to Mr. Alakesh, so can you give some insights on futuristic polyolefins for sustainable growth?
Hello. Yeah, thanks for asking this question. I think this is a very interesting question. You know that polyolefin is a wonderful material. Nowadays, you go for any application, you take the name of starting from healthcare, construction, packaging. So polyolefin is the key material for the future. So, but the polyolefin was developed quite long back. So in the year of 1950s. So after 1950s, lots of development is taken place in the polyolefin. So if we take the example, I will cite few examples how the polyolefin product has been modified with the time and how it can show is sustainable growth as per the market requirement. So I'm citing the one very basic example. Everyone have seen that the metal container, the 200 liter chemical was packed in the tin container, so 200 liter barrel. So when it is a huge product weight as well as very difficult to put in the inside the container. So then people have shifted from the tin container to the plastic L-ring drum, large blow molding container. So what happened? Earlier, polyolefin was in the very soft, it cannot able to take that strength. So for better strength, the molecular architect has been changed and make it a bigger molecule. So for making this bigger molecule, lot of modification has been done in the technology part. Earlier, it was produced in the single loop process. Now the advanced dual loop process has been produced. So Chevron Phillips is one of the pioneer in this technology, and this technology people are able to produce this high molecular weight as well as L-bin drum for this application. So coming to the second application, there is a you know that in household application all are using different types of plastic material. So these are the clarified plastic containers are coming with which is made of the polypropylene or random polypropylene material. But random polypropylene does not have that enough strength which is required for the big container. So high stiffness polypropylene was evolved. So for high stiffness polypropylene, there is a lot of technological advancement takes place. Earlier, the polypropylene was produced by the Spheripol technology. But now the Spherizone technology is come, and Spherizone technology can able to offer the polypropylene random copolymer having the very high stiffness compared to the normal polypropylene process. So around 200 2000 to 200 hexagonal modulus can be achieved with this technology. Similarly, in case of the HDP product, lot of modification done with respect to the molecular architecture. Earlier, in case of all injection molded products, so caps and closure application, normal narrow molecular rate injection molded product was used. But now the multimodal concept or multimodal or broad molecular weight injection molding products has evolved, so which can reduce the product weight as well as the smooth processing and lower energy costs. So again, steps towards the sustainable growth. I will cite another example. I think that water management is a crisis nowadays. So for water management, the pipe has a very unique role to make the water or transportation of water very smooth way. So in HDP pipe domain, earlier the P100 pipe was used by the many peoples. Now the people are not restricted to the P100 pipe. They are getting more sophisticated or high performance pipe material like P112 is already developed. Some it is commercially launched by some of the producer. But again, the research and R&D is not stopped here. So beyond that, people are thinking for the 117 pipe rating, pressure rating of the pipe, and it is still in the yet to commercialize, but already some testing is going on in global scale. So in future, the high strength pipe will become. But again, people are not stopped in the 117 rating of the pipe. They are thinking, they are innovating to modify the product. There are new concepts have been already conceptualized. The pipe can be processed in biaxially oriented process. So during the processing, the pipe product will be modified. So a lot of innovation is taking place for making the new generation of the product. Similarly, the MDOP is a very latest development which goes for the mono material solution. So a lot of futuristic polymer or development is taking place in the polyolefin segment. So we can say in a single word, so polyolefin is ready to reshape yourself to take the challenge for the future need of ours.
Thank you, Alakesh, for those live examples. Gurmeet, the push towards green chemistry has been a fundamental approach for companies aiming to reduce their environmental footprint. So the development of bio-based chemicals and biodegradable materials is obviously an alternative being looked at, to traditional petroleum-based products. In this regard, how are you and the industry looking at, newer feedstocks, renewables, biomass plants, algae, CO2, etc.?
Prashant, you are bang on. As almost all the industries have already announced net zero goals. And to achieve those net zero goals, now the companies at present are focused on, firstly on the scope 1 and scope 2 emissions. Then lately, all the companies will have to transition to scope 3 emissions as well. And if we have to achieve all those set goals and also to meet the targeted scope 3 emissions as well, so we have to look for the carbon source which is beyond fossil fuels. whether it is crude oil or the NG is what we are getting imported at presently major into India. So as a company also, and I belong to the R&D fraternity, and we are, as a company also, from R&D perspective, from the industry perspective also, all the companies are looking forward to developing the products which doesn't or don't require the carbon which is sourced from those traditional, what we call as old carbon also. So we are trying to develop the methods, trying to extract those valuable molecules from the biosources, and also, as you have mentioned, from the CO2 as well, so that we can convert them or you can utilize them to produce furthermore molecules. And one example I can share with you is the 3G plant which we are constructing, and it is under progress at our Panipat refinery. So whereby we will be capturing the CO2 emission from our MEG plant, and then we are going to convert it into the ethanol in the first case. So such technologies are where our the industry is moving ahead. And another thing is, even the products which we are developing at the which are at the infancy or at the lab scale itself. So there itself now we are targeting for any new product development to be more environmentally benign, to have the feedstock which is renewable in nature. Can we source it from renewable sources? So these are the now questions which we ask ourselves first before we start any new project. If I am going to say from R&D projects, it may get translated in 2 years, it may get translated into 5 years. But yes, if I have to be there on the longer horizon, I have to first ask me the right questions. And this is the first question now what we ask ourselves before we put anything onto the drawing board, that what new we are going to do, how we are going to make our product more sustainable. If my product will be, if I look on the longer horizon, say for a decade or so, so if my product will hold promise at that time, yes or no. So if I answer all those questions, I am able to design all those right products. And CO2 is another one feedstock where we are trying to convert them into some petchem raw material, which will again a feedstock for our next generation products. So yes, industry is well focused on that, and not only IOCL, but I am sure that all our fraternity across industry and R&D in India are working on such projects.
Yeah, thanks, Gurmeet. Mr. Nagaiah, innovation in the chemical industry per se has been slow. I have an example here as a point of comparison. Amazon spent 73 billion in technology and infrastructure, a component of which was in R&D in 2022, while the entire US chemical industry spent 13 billion. Some of the slowness is structural, arising from the asset-heavy nature of the industry itself, longer innovation cycles compared to, say, software, enhanced regulatory consideration, and less distributed customer base, primarily B2B kind of offerings. How can innovation be made faster in the chemical industry? I know you spoke about the Chinese having a very dynamic institutes or university-led innovation. So what are the other points that you could highlight?
The most important other points. Nobody is discussing about this. We are sitting this Indian Chemical News Petrochemical Summit 2024. We are sitting and discussing in the hotel, but the outcome is most important. Here is government first has to support from the Indian R&D, that is most important. The most important need talent, manpower is most important. And why how means almost all parents are telling why organic chemistry is so damn difficult to don't take chemistry. This is the truth I am telling. This is the truth. And we need a talented manpower, especially in the chemical industries. And now you go any private colleges, all chemical engineering seats are vacant. And whoever is running presently from the old people who completed for the chemical engineering, who completed for the chemistry, they are doing so. Here is the second point is the talent manpower. The third most important, infrastructure. It required the ecosystem, like that ecosystem is the same in the one campus. Somebody is doing something, somebody are publishing, but we are not thinking about where that end of this results will go to. That is the infrastructures, and states government support is badly needed. A state government badly needed means the state governments and the central government to publicize, because you take USA, you take the Europe. They are advertising you go for the chemistry, you read the chemistry. How many Indian industries or Indian universities telling and going to in the ground level, like intermediate stage and the degree stage, UG and PG level, go read, and how many people are telling? The truth, I am talking of the truth. So this is most important, the pollution clearance. Now somebody is talking in a previous section. The pollution clearance. Here these things are very straightforward other countries. And coming to the resource of the starting material. That is the biggest problem. For this, the talent manpower is most important. And the water also is the most important. Electricity. And public support is most important. These are actually for the missing from especially for you want to do something good for the Indian society. What my request for the industries who are sitting in this audience, and at the same time this platform I am requesting, ask to include in the curriculum itself from the intermediate onwards for the chemistry. Tell about the chemistry, everything is chemistry. Because chemistry, you take polymers chemistry, you take the plastic chemistry, you take the biodegradable chemistry. So every chemistry involved. So ask to this in the UGPG level curriculum for the technologies which are coming, novel technologies in the syllabus is most important. And industrial support is also the most important. When you are taking the clearance from the government, you are telling we will educate some of the school people and something you are telling. So my humble request, educate and propagate, ask to read from your children as a chemistry. That is valid. Otherwise, another 30 years very difficult in India. So think about this. How to encourage from this school level, that is most important. Common households and forever chemicals, like most important here is to the raincoats who are using. They are using forever chemicals, and shampoos regularly using forever chemicals, and the nail polishes and pizza boxes, and some of the cooking area they are using for this. The big debate is going on in Europe, especially in USA, where they are giving the funds. Last Biden government is the big discussion, especially for forever chemicals. My humble request for the Indian industries who are using this forever chemical who are importing to the India. You think about these things. And coming to your point, collective effort is most important to do whatever the things. And a collective means especially for R&D as to support industry. Universities support to industry. And at the same time, the universities and R&D institutes, what they want for the support of the industry. So this is the mutual understanding. Sir, we don't have money, but we want to have this. Because you are already teaching, same time we need this support from the institutes and the universities. So this collective collaboration is badly needed. So that you want to take further. This is my personal and art feeling I am putting into use.
Sure. Thank you, Mr. Nagaiah. There was a round of smiles when you said children are not encouraged in chemistry. So there was quite smiles around the room. Coming to Mr. Alakesh, how is the advancement in catalysts and additives in your assessment, for a toxic-free future?
Okay, Prashant, it is a very, I think it is your insightful thoughts on the futuristic material. So catalyst and additives. Catalyst and additives has a key role in developing the high performance polymer or any material. But unfortunate part is that there are many catalyst or chemical is there which is not good for human health. So we have to use the all types of catalyst and additives with judiciously. So I'm taking a single example of applications like the polypropylene process. So polypropylene is being produced by Ziegler-Natta catalysis, where the unfortunate part, some of the component as an internal donor, phthalate is being used. Okay. So although whatever polypropylene is coming to the market, all phthalate with the permissible limit, and that is good for everyone. But if you see the global trend, people are moving out from the phthalate catalyst to normal regular catalyst. Okay, so there are other solutions available. So for this type of application, the phthalate free catalyst is give the better mileage of the PP production as well as that is safe product for any food contact application. So we can say we have a petrochemical plant complex in the Punjab Bhatinda. So we have set up the new polypropylene plant which is operating with a completely phthalate free catalyst. So that is, we can say we are moving towards the toxic free future for producing the polypropylene without any phthalate catalyst. Coming to the other applications, there are few critical applications, like I'm saying the example of the medical devices. You know, all medical devices, that's injection, syringe, and the packaging. Earlier, it was sterilized by the ethylene oxide sterilization process. But with the global scale capacity and the line speed of the packaging line, so that sterilization process has been shifted from the normal ethylene oxide to the gamma sterilized process. So when high beam gamma sterilization is done on the polypropylene material or polyethylene material, sometimes few additives used in the product which is degraded and produce some 2,3 tertiary butyl benzene sort of product which is not good for human health. So, but lot of research is going on and people are already developing the alternate additive to making the polymer or the material free from this type of degradation at high electron beam. So their solution is available, global product is ready for using this type of product. There are few additives which used in as a primary antioxidant in the polymer. So these are also degrading and giving Arvin series of chemicals. So this Arvin is also not good for human health. Again, the alternate additive has been developed. So lot of development in catalyst and additive is going on. New generation catalyst has evolved. The new generation catalyst gives the better mileage. So again, the catalyst rated in the final products will be limited. So with respect to catalyst and additives, these developments are going on, and automatically it is helping for our sustainable future and toxic-free future at good human health.
Yeah, thank you, Alakesh. Coming to Gurmeet, so due to the global compulsions towards circular economies, manufacturers of chemicals and polymers are exploring strategies towards waste management and resource usage. To this effect, waste-to-chemical technologies and closed-loop recycling are being explored. So, what is your take on this, trend, and how is IOC sort of catalyzing this process?
As Alakesh has already mentioned, polyolefins are it's a very beautiful material, and we can call it now omnipresent. It's everywhere. We can't escape that one. But it has got a bad name also due to the littering which happens not because of the product but because of the nature of humans. We litter. Polymer doesn't itself litter. And considering that fact and also the fact that polyolefins are the largest produced plastics, so the lot of onus is on producers like IOCL, HMEL, Reliance and others to, as part of extended producer responsibility also, to devise methods how best we can recycle back those products into the mainstream. And as a company, IOCL has already taken that initiative, and we are already in big way into the mechanical recycling. And where we have products into the market with the brand name of Cycloplast. So basically what we are doing is we are gathering all the waste polyolefins, polypropylene, polyethylene. We have the right segregation done, and then we are again making the pallets which the end user can buy and you consume it. So, and that is itself a very big, we can say, contribution to the pathway what you have also mentioned towards sustainability. And that is the mechanical sustainability. Whatever plastic can be mechanically recycled, we should do it. Next phase comes, as you have already very aptly mentioned, is the chemical recycling. The end of the life waste which can't be mechanically recycled has to convert it back into the chemical feedstock. And that is also where we are working extensively on the different projects. Around 2 years back, we have taken up a big trial in one of our Northeast refinery also, where we produced BS6 fuel from waste plastic, which was actual real waste plastic. And then we are trying to convert all those waste containing polymers into the feedstock. Actually, the way we see it, Indian Oil is, it is the carbon economy. And from wherever we can source that carbon more sustainably, it is going to value add, and also in turn going to help us in achieving our net zero goals and scope 1 and scope 2, and later on scope 3 emissions also, because all this will come into the picture when scope 3 emissions get implemented. So, and we are investing heavily on all such technologies to recycle it back. Like also we are producing lube oils. So we are also working on how to make, convert it back into the closed loop, so that all that waste lube oil at present, which is not into very controlled market, but few smaller players are there, which also have impact on the product quality, recycled product quality. So once companies like IOCL enter into that domain, the things becomes more streamlined, and already those producers and segregators become part of that value chain, and the quality of the product is ensured for the end user as well. So we are working both from the commercial perspective and from the research perspective and integration of the already existing value chain. Thank you.
Thank you, Gurmeet. Mr. Nagaiah, what is the difference between compostable and biodegradable plastics? Are these two can be used interchangeably?
Yes. Actually, this is the main, actually, how many industries are there now sitting in this audience? Just raise your hands. Only two.
No, two are on your left and right also.
Okay. Okay. The most important, actually, the Indian industry confusing the two public. This is the truth, especially in biodegradable plastics. Because this is the truth, because my observation, came from the villages, in Telangana village. How it is confusing, believing that the composting plastics and biodegradables are the same. But this is not correct. The important in this plastic industry, most of them are compostable plastics. And human intervention is there. But biodegradable plastic, natural process. And that takes a lot of time. There is no time limit. This is the fact. So what we are thinking biodegradable means everything will decompose. That is not the true. So the plastic material defined as a bioplastic, if it is either they are the bio-based or the biodegradable or both. Not all bioplastic are biodegradable. This is the truth. So bio-based can be defined the material which fully or partially obtained from the biomass plants. Now we are telling the corn and sugarcane and all these things. Here the industry must be, if you are using corn, if you are using sugarcane, so what is affecting other side is most important. If you are using sugarcane, cow and all these things, there is the feed stack actually. If you are in the corn, like some of the countries where South Africans, wherever the poorest poor people are living, their corn is the actually so it will arise the food security problem. So keeping this in the mind of the Indian plastic industry who want to use corn and sugarcane, you have to think same time what is the consequence from the other species. That also is important. So biochemical process will which microorganisms convert into polymers into carbon dioxide, water, methane and compost. So here the degradation product depending on two systems, on aerobic and anaerobic, and this I don't want to tell the chemistry, but enzymes are the responsible for the biodegradation, and microorganisms, they grow in the polymers, big fragmentations, ultimate degradation. So if your PLA degrades only industrial compositing with high temperature, you have to maintain 60 degree, does not degrade landfill or the dump yards. This is the truth. So the biodegradability depending on the molecular weight and structure and the crystallinity of the polymer. So biodegradability occur naturally, the human intervention. So what I want to do, they are not on the same. This I want to tell from the audience as well as the industrial people. So think wherever you are using the term of bio, same time you are also coming from the society. So consequence is most important than our products.
Thank you, Mr. Nagaiah. Just a follow-up question. What would be the, from you, what would be, how do you fire up the Make in India initiative for, and, innovating for that? What are the key asks that, you feel for, more robust Make in India?
Innovation in point of view chemicals, innovation in point of the fine chemical, innovation in point of the which which area the platform is
No, broadly, in terms of both feedstocks, innovation, in all the aspects, faster clearances.
The innovations, whenever the innovation is, you are any industry is expecting. Incentives, are the government expecting? Are the industries expecting? Are anybody is expecting the innovations? Means here is the research, R&D is most important. Without R&D, we are exporting from the fine chemical, we are exporting drugs from we are in the third. You take the USA market, every 3 pills one up from India, but we are only doing from the copying of the technology. That in the invention ecosystem to create industry or the create government is most important. Here is the why one of the IT, why they are doing from the IT, there is a job security problem. They are working from the 18 hours, 16 hours or 15 hours in the Indian artificial, whatever the computer people. But coming to the chemistry or coming to the industry, we are going 10 o'clock, we are coming 6 o'clock. How much time you are spending for the invention? So think this of the system of the ecosystem is otherwise getting coming from the 8 o'clock, 10 o'clock going 6 o'clock will difficult. This is the fact. So this is collectively industry people and institute peoples and the university people has to think collectively, make some note to put for the government. Then only we will get the discoveries, frankly tell, only telling. But if you really discover is nothing. Nothing means it is maybe 5%, maybe 10%, not even not 10%, 5%. This is the, so getting the in a new product is very difficult task. A difficult task. Sir, this is
Thank
my
you, thank you. Yeah, thank you, Mr. Nagaiah. Alkesh, how is your organization contributing to the, the Make in India initiative?
Okay, sir, actually HMEL is organization, basically we are in the refining business. We produce the petrol, diesel, gasoline. So along with this, we are come up with the petrochemical complex in 2022. So we are operating around 5 different polymer plants there. So government has thinking that whatever the polymer is coming to the India, so we should develop it in-house. So to support this government initiative, I can take a name one of the grade, that is the large blow molding grade, that is LBM grade. It is basically the Marlex produced by the Chevron Phillips. India is importing around 200 KTA of this polymer to India. India is completely dependent on the import. Nobody is producing this particular grade in India. So in HMEL, we have started the production of these grades, and definitely we have reduced the import dependency, and gradually maybe it will be in-house production only. Similarly, from the same complex, same plant, we are producing another medical grade, blow molding grade, that is very unique, and that is also, there is an import dependency for this grade. So we are already start producing of this grade. So these are all about the, we have reduced the import dependency in the HDP segment. Coming to the linear low density polyethylene or LLDP segment, yes, lot, as sir is nicely told, that India, lot of things, India is making polymer, but all technology is licensed from the outside. No technology is available in India. So like this metallocene LLDP is a very unique polymer, which is a high performance material, which is need for all types of the packaging application. So nobody producing this metallocene LLDP in India. So HMEL has started the production of this metallocene in India. As of now, I think India is importing around 4 lakhs ton of metallocene LLDP every year. So it is completely dependent on the global production. So no production is there. So we have started production, and we'll keep on continuing the production for this particular metallocene LLDP grade. So this is again the one step towards the Make in India initiative. Coming to the another different types of specialty HDP film grade, that is the hexene based C6 based HD film or C6 based HM film. So these are the very high performance film which is suitable for the down gauging or packaging applications. So we are producing, this is a unique in India, only we are producing this particular hexene based HD or HM film. In case of the polypropylene segment, yes, we have produced a few grade, which is again the Make in India supportive. As of now, India is importing around 50 lakhs tons of polypropylene impact copolymer, which is produced in the reactor. There is a reactor grade impact copolymer is mainly for the automotive application. So we have started production that's grade, the reactor grade of impact copolymer in ICP segment. So these are the small things, but again steps toward the Make in India initiative. And we also in the chemical segment for these type of polymer, different types of HDP, we need the butene as a co-monomer. So we have our own in-house production unit for butene, so we do not depend on the butene import or something. So these are the steps that we have taken for supporting the Make in India initiative.
Yeah, thank you, Alakesh. Gurmeet, Mr. Nagaiah was talking about innovation. So do you think there is a dearth of the R&D and innovation in the Indian chemical industry? Most of the companies in India are at sub 2% of the sales in terms of R&D expenses, whereas some of the innovative companies of the West are as high as 7 to 8% of the sales. So what are your thoughts on this?
I look at from the different perspective. I am an R&D person, and my management looks at how much confidence I am having on my development. I joined Indian Oil in 2010, and by 24, my group has already exceeded 150 granted patents. That's a big number. I can boast of it. And why we have been able to achieve so much is, the first question we ask is, are we doing the right thing? And if not we, then who else? And some of the industrial problems, what we have taken care of, like Alpesh was also mentioning, the newer generation catalyst systems, the catalyst systems which we are getting, say, from example, from our licensor, can we better it? Yes, we can better it, but we have to set our targets really high for that, and you have to put in your blood and sweat into it. I will give you a few examples where we have succeeded by doing so. First is we developed a catalyst for producing polypropylene. We are producing polypropylene, and Alpesh is also producing polypropylene. And the catalysts are all imported as of now. And when we developed the catalyst system, we scaled it up. Our management was very supportive. Again, what confidence we can give to our management. We tested our catalyst in a small reactor, which produced half a kg of polypropylene. And then we undertook the plant trial, and the plant was running at 30,000 kg per hour. So the scale of the magnitude was to the order of 60,000 times. But yes, that is the confidence. If we show to our management, the management is also ready to take that risk. And this is one example, and now we are continuing with many such more development and other things. So if we are ready to take the risk, the systems are changing in India. The companies are also now quite supportive. Yes, we have to fight a bit, but that fight has to be there for each and everything. Even from coming from Faridabad to over here, I was stuck for almost 45 minutes in a single place. So it has to be on a daily basis. Another very interesting product was a drag reducing agent, which goes for pipeline transportation. And again, whosoever has traveled by a car driven by petrol or diesel will have a bearing of the product what we developed and we commercialized, which is the extra flow drag reducing agent. When we started that development, that polymer, the polypropylene and polyethylene IOCL or HMEL are producing, is having molecular weight typically 2 to 3, 4 lakhs, in this range only. The polymer which goes into the production of drag reducing agent is having molecular weight of around 2 crores. So it was not a small time jump, but it was a magnitude order difference. And when we started that product, India was importing that product from only 3 companies, all based in USA. And people ask us the question, will you be able to produce such high molecular weight product? Will you be able to develop those process, the catalyst systems to produce all those products? And then the next questions what were faced were from our the operations team. Will you be able to maintain the quality what those Americans are producing? They are producing now for decades together. We started production in 2021, and that time in Indian market of that product was closer to 1,000 KL per annum. Last financial year, IOCL sold product for around 2,600 KL. The value we offered to the market for a product which was earlier all imported, the rate we offered, it offered value to the end of the day. If if you have to force customer to buy your product, it has to be through value. And most of the things now what we are talking about is B2B, it's not B2C. B2C is entirely a different challenge. For B2B also, all those price sensitivities and what value we are going to offer comes into the picture. But the message is, if as industry, we have that conviction to do it, we can do it. But somebody has to take on that risk, and who is going to be that somebody, it is a very big question. In the catalyst case or the drag reducing case, that somebody was me. But in every industry that we will have those somebodies here or there. So if they take that onus, they show the conviction to the management. The way the India is progressing, the companies are now ready to take that risk. Now even our operations people have got much more confidence on our product. And another very beautiful thing is that once we have taken the trials of our own catalyst systems, the prices of the catalysts have also come down in the Indian market, because all those producers who were exporting to India, they have understood that where we stand and what price band we can hit into the market. So that is the way Indian R&D can force the complete transition at the market, even for very critical B2B segment products as well.
Yeah, thank you, Gurmeet. Sir, my last couple of questions, one to Mr. Nagaiah. Sir, there is this whole concept of AI-assisted chemical discovery, where AI and analytics are used to sort of predict new chemical molecules and combinations to solve problems that are not solvable from the traditional chemicals till date. You as a scientist with CSIR, how do you assess the adoption of AI by the Indian chemical industry? That is one. Also, a part of it is that, are we moving fast enough and innovating fast enough to capitalize on this huge, battery chemicals, EVs, this whole sustainability transition, or are we, not up to speed?
Sir, first, the simple thing, battery chemicals, you are asking the battery chemicals. Yeah. The technology is not available in India. If you want to take that technology, you have to Taiwan or the Korea, and those people are very strong on that area, especially in the battery chemicals. Because here is in Andhra Pradesh, there is a one, the institute, the lithium or the battery, but we are working, there is no doubt at all. But the technology, whatever you want, now the green cars and all these things, though it is required a lot of research R&D, that is most important. Coming to the artificial intelligence in the drug innovation. Whoever is talking in India or whoever talking the worldwide artificial intelligence, they started at the same time. Nobody is an expertise in the artificial intelligence in the world. I am talking not only in India. But they are started the things. But it's required a lot of the things. Whatever we are feeding in the, whatever we are putting in the computer. So that giving only for the 3D pictures. But working manpower, talented manpower is barely needed. And traditional, whatever the traditional is there, why you want to jump? You concentrate on the traditional which are available for the acetic acid or the maybe these things we are doing in India in the olden days. And now it is missing. Now it is missing. Think about our expertise, our things, own things. And our Prime Minister is every time is telling Atmanirbhar and Vikas Bharat and Atmanirbhar Bharat Amritkal. This is by 2047 we want to increase per capita of our humankind of the 10,000. For the 2008 rupees to 10,000 means you give the whatever the technologies in the olden days, not running from the 2047 to till date 2024. Without the artificial intelligence, without these things. So what I want to say, give work for the people. Give work for the people, not for the government, for the Indian industries. And what Indian industry is looking, I am getting from the N-1 product from the China, N- product from the South Korea, N- product Europe. So what I want to say, artificial intelligence in the drug, maybe the computer gives instead of 15 years, it may give for the 10 years. But the time period may be 1 or 2 years. But how much you are spending, that is only give the tentative figures. But to finally have to synthesize that compound. So talented manpower is most important. For the parallel use from the technology, there is no doubt. And now everybody is using from that whatever the by sale we are, that whatever the transaction is, things is good. There is no doubt. But same time, you don't miss your culture, you don't miss your traditional technologies. That is most important for the Indian growth. Because MSMEs, you take from this Japan to South, I am a visiting scientist from South Korea. Those people are depending on the small people who are working in the village. They are giving the work to the village people. They are not coming to the towns. Now you take from in India, most important, we are Mukherjee Nagar in Delhi, Ashok Nagar in Hyderabad, and one more is Kota. They are spending, intellectual are only after this completion, they are studying from the IAS. How many people? Only 5% they are getting. What about the rest of the things? So you give there is a good manpower. I told in my initially, there is a skill manpower is there. Skill students are there. Skill knowledge is there. So these things to use properly from the government as well as the industries. and universities and the same time use technology. There is no, but the artificial is not a solution to the drug discovery. Ecosystem is the most important to develop a drug discovery are the things is that ecosystem, it required the organic chemists, it required the pharmacologists, it required the toxicologists, it required all the analytalists. So it is a collective effort. This where is the existing this type of the single ecosystem in Indian institutes or Indian universities or Indian industries? There is a questionable. So where the without this, why want to go from the immediately to jump from the artificial intelligence? That is my personal opinion.
Yeah, thank you, Mr. Nagaiah. Just the last closing question to Gurmeet. Taking a cue from Mr. Nagaiah's question, answer. The Indian chemical industry is plagued by high dependence on imports for the basic building blocks on China, such as, acetic acid, methanol, ammonia, likewise PVC as well, as was discussed in the previous panel. So this dependence remains embarrassingly high for India. Additionally, what we are seeing right now is that China is providing a lot of PLI kind of incentives. Some consultants of clients of ours were telling that it's about 13% for intermediates and 9% for active ingredients. How does the Indian industry look at these threats from China and also this whole ecosystem of dependence on imports, and does innovation at some level get impacted because China has this whole ecosystem? For example, again, thiophene is produced. It's a basic building block. It's a kind of a chemical for many chemicals, and it's only produced globally in China. So, how can the industry wrap its head around some of these threats, Gurmeet?
Yeah, for such threats, I think we have to take case by case, one product by each product at a time. The China has got that advantage of huge manufacturing capacities. Actually, rather some of them are over capacities, which gives them a distinct price competitiveness. And as Prashant has mentioned that yes, those unfair trade practices and dumpings are also there. Some of them are officially also through the route of PLIs and other benefits which Chinese government is offering. But Indian industry, if has to overcome, it has to overcome through R&D only. That ecosystem has to develop, as Sir has also mentioned. But now, if I look from that perception or from that perspective, rather, the main challenge is with the manpower also. And Sir has very aptly mentioned regarding the manpower. India is now transitioning from a service-oriented economy to manufacturing-oriented economy. But our education system hasn't transitioned accordingly. The biggest challenge what we face is we are not getting the right manpower quality. The new generation which is coming up in the market for jobs, they are very much happy in the service sector. You give them a PC to work, they will work there for 10, 12 hours. You send to the bench to do some work, to do actual chemistry or bench scale reaction, they are not very happy in doing all those things. So that changes needs to be done at the education level itself, from transition from service to manufacturing. Another very interesting example is mechanical engineers. After doing the BTech, they are not even they don't even know how to weld. So, and now there have been cases in my extended family also, where they have got their own, they are entrepreneurs, so they have got their own units. Kids have done BTechs, and then their parents are sending them to do the diploma so that at least they get some hands-on experience, so that they can work in the factories with their own hands. Till they don't understand that thing, they won't be able to deliver the thing. That transition, Sir has very clearly mentioned, has to be there. And yes, R&D is going to be the cornerstone, and we have to keep abreast with the tools like AI, ML also. The way the things are moving for many of the drugs which have been discovered are just based on these tools. And with developments like launch of Willow by Google, so all these things are becoming reality. What calculations used to take years together, um, they now take maybe a week or so. And many such tools have already been launched in the market. For example, uh, I got one PhD student along with IT Delhi. So we worked on DFT modeling of Zignatic Atlas systems. They used to take 3 months, 4 months time to model some of very basic structures. But now if I look at currently their models are available, the same calculation we are able to do within maybe a day or so. So from 3 months, now we are talking about 1 day time period. And if things like Willow come into the picture, it may be a matter of minutes only. And we have to keep abreast with such things. Otherwise, we will always be lagging behind in that development curve. So what China has also done is they followed Western companies. They saw where the development is going on. They started to walk, then run. And now in many of such technologies, they have already exceeded their Western counterparts. And EVs are one such examples. And even India, even Mahindra is buying blade batteries from BYD. So, but we have to start walking at least, then run, and then only we will be able to overtake all and overcome all those challenges. Lean manufacturing, being cost competitiveness, looking inward sources like drag reducing agent, what I talked about. The way we designed the product, yes, we were very aware that China is also going to launch the similar product, but the way we designed our production process, China can never compete with us. So all we have to be perceptive of all those things. We have to be very cautious, and when we design any new process or any new chemistry, we have to jot down and keep all those things in mind at where we stand vis-a-vis what we have also got our own strengths, so we have to encash on those to deliver for our own nation. Thank you.
Sir, in continuation actually. Sir, what is, sir has told is excellent, correct the problem. The thing is, most important is, I am talking about as a chemist APIs. Here is more than a 50 or 100 big companies are making the manufacturing some of the chemical components. You take the whatever the Cipla, many companies by it is there in the Maharashtra, in Punjab, in all over India. In the last meeting also I suggested from the Indian industries people, you need one of the APIs in large quantity. So you have the good manpower is there in India, there is no doubt at all. You make your own APIs, along with you make 5 more APIs, you will get the market also. So like if every company is making with his own product along with the 5-4 APIs in capacity, whatever the skill is there, whatever the infrastructure is there. So for example, 150 companies into 5. Each 5 into 50. 500. So maximum we are using 200 to 300 APIs in Indian industrial production. So it is available in India itself. So this is missing. This is missing is the collective effort of the all Indian industries who need from you market from the small companies. You make your product along with the whatever the APIs required from the some of the things. So this is why it is missing. Miss in China 20 years back. They are not strong in this area, but they invited for intellectual all over the world. Is sitting in the campus. Is sitting in the industry in the middle and is training to all the people. There good youth is there in China, good youth is there in the skilled people is there in India also, but we have to utilize properly our strength. That is the leader. That institutes are our premise, our country. So this is the most is missing, sir, actually. So we will sometimes it is stopping is difficult. So think in this direction. That is my request to all the 3 people, industry and institutes as well as the universities.
Thank you, sir. Thank you so much.